Stand in the center of Stonehenge and look up. You are told you are looking at sandstone. You are told this is a temple built by farmers for the solstice. But if you take a microscope to these stones, the story collapses. These blocks are 99.7% pure quartz crystal. In the modern world, we don't use quartz to build walls. We use it to build oscillators, transducers, and circuit boards. Why would a Neolithic farmer drag 40-ton crystals for 20 miles just to mark the sunrise? The material properties alone force a question that archaeology has avoided for a century. If the stone is industrial, the function is industrial. And if the function is industrial, we need to stop treating this site as a ruin and start treating it as dormant infrastructure. Let's begin with the hardness problem. The official narrative states that Stonehenge was constructed around 2500 BC by Neolithic communities using tools made from red deer antler, bone, and stone. For shaping the sarsen stones, archaeologists cite the use of sarsen hammerstones, essentially balls of the same stone, used to pound and peck the surface into shape. This sounds plausible until you examine the Mohs hardness scale. Sarsen stone, which is a form of silcrete, registers at 7 on the Mohs scale. That is the same hardness as quartz. It is harder than steel. By comparison, a red deer antler registers between 3 and 4 on the same scale. Bronze, which wasn't even available to these supposed builders, sits at 3.5. Iron, which came much later, reaches only 4. Chalk, the bedrock they were supposedly excavating, is between 1 and 2. Here is the physics problem. You cannot cut, shape, or dress a material of hardness 7 using a tool of hardness 3 or 4. The tool abrades away. The stone remains. It is like trying to cut a diamond with a banana. The tool fails before the stone yields. Now, experimental archaeology has shown that you can fracture sarsen using percussion, essentially smashing it with another piece of equally hard stone. But the lintels at Stonehenge are not fractured rubble. They are dressed surfaces with planar faces and geometric precision. More critically, they are fitted with mortise and tenon joints, woodworking techniques applied to the hardest available stone. Creating a mortise, a shaped hole carved into the underside of a 10-ton lintel, requires abrasion and shaping, not just impact. The official tools do not match the precision of the finished work. Hold this information in your memory. The hardness discrepancy. In a moment we'll return to it, and you'll see why the tool problem extends far beyond Stonehenge itself. 6 miles to the north of Stonehenge sits the largest man-made mound in Europe, Salisbury Hill. It rises 40 meters above the surrounding plain. It is a monument to the impossible logistics of the Neolithic period, and the numbers expose the flaw in the official timeline. The mound contains between 240,000 and 325,000 cubic meters of material. That is approximately 500,000 tons of chalk and soil. English Heritage, the body responsible for the site, estimates that construction required between 4 million and 18 million man-hours. Let's take the lower estimate, 4 million man-hours. If you had a workforce of 500 men working 10 hours a day, every single day, with no rest, no illness, no winters where the ground froze solid, it would take you over 2 years just to move the chalk. But to achieve the higher estimate of 18 million man-hours, that same crew would need to work for 10 years without interruption. Now consider the population. The estimated total population of the British Isles during the late Neolithic, around 2500 BC, was likely between 100,000 and 250,000 people, spread across the entire landscape. The population density of Wiltshire would have been extraordinarily low. A concentrated workforce of 500 able-bodied men, plus the support staff required to feed them, house them, and maintain their tools, represents a logistical operation equivalent to a total war economy. And here is the critical gap. Where is the infrastructure? Where are the middens, the rubbish heaps from feeding 1,000 people for a decade? Where are the temporary settlements? Where are the kilns for making pottery, the storage pits for grain, the evidence of the supply chain that would have been necessary to sustain this project. The site is archaeologically sterile. When excavations were conducted inside Salisbury Hill in the 1960s and again in 2007, the findings were described as surgically clean. No broken pottery, no hearths, no midden layers, just chalk, turf, and the occasional organic inclusion like antlers or insects, preserved in near-perfect condition by the thermally stable environment inside the mound. At this point you might think, perhaps the evidence was destroyed by later activity, or perhaps they cleaned the site as they worked. And that's a logical thought. But the absence of evidence at this scale is evidence in itself. A project of this magnitude, using the stated technology and workforce, should leave a forensic signature in the soil. The signature is missing. So we return to the hardness problem. If the tools don't match the stone and the workforce doesn't match the labor, what does match? The function. In 1958, a man named Robert Phillips was contracted to drill into Stone 58 at Stonehenge. Phillips worked for Van Mops Diamond Tools Limited, a firm specializing in industrial diamond drilling. The reason for the drilling was structural. Stone 58, part of the Great Trillathon, was fractured and unstable. The restoration team needed to insert metal rods to reinforce it. Phillips used an annular diamond core drill to bore horizontally through the 1-meter-thick stone. The drill extracted 3 cylindrical cores of stone. 2 of those cores disappeared into the archives. The third, Phillips kept. He took it with him when he emigrated to the United States and kept it in a plastic tube in Florida for 60 years. In 2018, on the eve of his 90th birthday, Phillips asked his sons to return the core to English heritage. It was only after the return of this single sample that Professor David Nash was able to conduct the destructive geochemical analysis that revealed the sarsen stones are 99.7% quartz crystals. For 6 decades, the material properties of the most famous megalithic monument in the world were unknown to the scientific community because the samples were either lost or held in private hands. This is not an academic oversight. This is a data suppression event. Whether intentional or accidental, the result is the same. The geological reality of the monument was concealed until 2018. Note this detail. You'll soon understand why the suppression of the Phillips core matters far beyond the chemistry of the stone. Let's now address the site's current status. Stonehenge sits inside the Salisbury Plain training area, the largest military training estate in the United Kingdom. The Ministry of Defence owns approximately 150 square miles of Wiltshire. That is 11% of the entire county, effectively quarantined from the public under the guise of national defence. The plain is marked by red flags, perimeter fences, and danger signs. The official justification is public safety due to live firing exercises and unexploded ordnance. The practical result is a 150 square mile black box. Within this zone, the military is the sole custodian of approximately 2,300 recorded archaeological monuments, 550 of which are legally protected. Public access is controlled through bylaws that prohibit entry into wooded areas, the use of metal detectors, and any form of digging. Casual exploration is a criminal offence. The Ministry of Defence operates with impunity inside the perimeter. Heavy engineering equipment, earth movers, and tunnelling machinery can be deployed without civilian oversight. The public sees nothing. Archaeologists see what they are permitted to see. 6 miles to the east of Stonehenge sits Porton Down, the Defence Science and Technology Laboratory. Established in 1916, Porton Down is one of the most secretive military research facilities in the world. It has been historically linked to the development and testing of chemical and biological weapons, including anthrax, sarin, VX nerve agent, and plague. The proximity is not coincidental. Porton Down sits on the same chalk aquifer as Stonehenge. The aquifer is a natural conductor of acoustic and vibrational energy, and the facility has documented interest in subterranean dispersion. In the 1960s, Porton Down scientists conducted covert trials in the London Underground, releasing bacteria to simulate biological warfare scenarios and measure airflow through tunnel networks. Why locate the United Kingdom's most dangerous laboratory on a major aquifer in a region packed with ancient monuments? The secure perimeter of Porton Down, protected by the Official Secrets Act, allows for deep excavation and geological study to be conducted without public scrutiny. If anomalous materials or structural features were discovered beneath the megalithic sites, Porton Down would be the logical facility for analysis and containment. Let's pause for a moment. At this point, you might think, this is simply strategic land use. The military needs space, and Salisbury Plain happens to be open and sparsely populated. That's a rational explanation. But consider the density of the archaeological features and the specificity of the security. Governments don't guard piles of stones, they guard assets. Now we turn to the evidence that has been removed from the record. Between 1901 and 1964, Stonehenge underwent a series of restorations that fundamentally altered the site. In 1901, William Gowland straightened Stone 56 and set it in concrete. Between 1919 and 1926, Lieutenant Colonel William Hawley excavated large sections of the site, straightening stones and digging extensively into the ditch and stone holes. In 1958 and 1964, major engineering works re-erected fallen trilithons and set nearly every sarsen stone in a concrete foundation. The Stonehenge you see today is largely a 20th century reconstruction. The stones that stand are the ones the Office of Works decided should stand, and the concrete matters. Setting stones in modern cement destroys the archaeological context of the original stone sockets. It removes any possibility of examining what was beneath the stones: foundation deposits, insulating layers, conductive materials, or ground connections. Whatever was under those stones is now entombed in concrete. This is not preservation. In forensic terms, this is tampering with evidence. The same pattern appears at Silbury Hill. In 2000, a collapse at the summit revealed the extent of internal voids and tunnels inside the mound. The largest void was created by a tunnel excavated in 1968 by Professor Richard Atkinson for a BBC documentary. Atkinson claimed to have found nothing inside the mound except layers of chalk and organic material. The tunnel was never properly backfilled. Photographs from the 2007 remedial work show a rusty metal door installed deep inside the mound, sealing the entrance to Atkinson's tunnel. This implies that access was maintained or controlled long after the excavation was supposedly completed. In 2007, English Heritage undertook a project to stabilize the hill by pumping 1,465 tons of chalk slurry into the voids. The interior of the mound is now permanently sealed. Any future investigation of what Atkinson found, or what he didn't report, is impossible. The forensic signature of these interventions is clear. Sites are excavated, data is collected, then the sites are sealed or reconstructed in ways that prevent independent verification. Remember this name, Imber. In 1943, the entire population of the village of Imber was evicted with 47 days' notice. The official reason was to allow American troops to train for the D-Day landings. The villagers were promised the right to return after the war. 80 years later, the village remains under strict military control, used for urban warfare training and known as a ghost village. Imber is located in an isolated bowl on the plain, geographically secluded. The refusal to release this land, despite decades of public campaigns and the end of the Cold War, suggests the location holds strategic value beyond infantry drills. The ghost village status removes any permanent human habitation from a key area of the Salisbury Plain grid. No civilian observers are present to witness nighttime operations or anomalous phenomena. Public access is granted only on a few specific days per year and heavily policed. Does this sound impossible? Let's check the precedent. To the northwest of Salisbury Plain lies a vast subterranean complex that proves the viability of massive underground construction in this region. The Corsham Computer Centre and the former Burlington nuclear bunker constitute a 35-acre underground city built into the Bluestones quarries. This facility was designed to house the Prime Minister, the Cabinet, and 6,000 civil servants for up to 3 months in the event of nuclear war. The complex includes over 60 miles of underground roads, a subterranean railway station, hospitals, and communication centres. Burlington proves 2 critical facts. First, the limestone and chalk geology of Wiltshire is perfectly suited to creating vast, stable underground networks. Second, the United Kingdom's military-industrial complex has the capability to construct and maintain massive subterranean infrastructure in total secrecy. The existence of Burlington is declassified. The extent of the network is not. This detail seems trivial. It isn't. If modern tunnels of this scale can be built and operated beneath Wiltshire without public knowledge, the possibility that pre-existing subterranean networks were exploited or expanded becomes far more plausible. Now we turn to what lies beneath the visible monuments. Between 2010 and 2014, the Stonehenge Hidden Landscapes project used ground-penetrating radar and magnetometry to map the subsurface of the plain. The results revealed a landscape far more complex than the standing stones suggest. At Durrington Walls, 2 miles northeast of Stonehenge, radar detected a line of up to 60 massive stones, some estimated at 4.5 meters in height. These stones were not ruined or eroded. They were deliberately pushed over and buried beneath the later earthwork bank. This is the so-called Superhenge. Why construct a massive stone monument only to bury it before it was ever used? In 2020, a ring of massive pits was discovered forming a 2-kilometer diameter circle around Durrington Walls. These are not post holes. They are shafts, 10 meters in diameter and 5 meters deep, evenly spaced in a geometric array. The scale of these excavations rivals the construction of Stonehenge itself. They are engineered features, not ritual pits. The subsurface infrastructure dwarfs the visible monuments. The stones we see are the tip of an iceberg. The network is below our feet. Imagine standing at the entrance to Atkinson's tunnel inside Silbury Hill. Your breath echoes off the walls. The air is cool but dry, and the temperature remains constant regardless of the season outside. The chalk acts as a thermal insulator, preserving organic material in a state of near suspension for millennia. Antlers, seeds, even winged ants, excavated from the core of the mound, appeared almost fresh. Now imagine descending deeper. The tunnel narrows. At the end, a rusted metal door. What lies beyond that door is sealed by 1,465 tons of chalk slurry. You will never know. Hold this information: the buried Superhenge, the sealed voids of Silbury, the 2-kilometer ring of shafts. In a moment, we'll return to these features, and you'll understand why they are not decorative. They are functional. A logical question arises here. If this infrastructure exists, why doesn't the mainstream archaeological community acknowledge it? The answer lies in the framework of interpretation. Archaeologists are trained to interpret sites through the lens of ritual, ceremony, and social organization. When a massive earthwork is discovered, the default explanation is that it served a symbolic or religious purpose. The possibility that it served an industrial or technological function is not even considered, because the framework does not permit it. But let's test the framework. Let's apply industrial logic to the site and see if the pieces fit. The sarsen stones are 99.7% quartz. Quartz is piezoelectric. This means it generates an electric charge when subjected to mechanical stress. Conversely, it deforms when exposed to an electric field. This property is why quartz is used in watches, oscillators, and transducers. It is an industrial material. The sarsen stones at Stonehenge weigh up to 40 tons. The lintels weigh between 10 and 15 tons. When a lintel is placed on top of two uprights, those uprights are subjected to immense, permanent compressive stress. From a physics perspective, the sarsen circle is a ring of high-mass piezoelectric oscillators under constant mechanical load. Now introduce vibration. Any vibration in the system, ground tremors, wind shear, or acoustic input, would cause the quartz to generate a measurable electromagnetic field. The site is not inert, it is a potential transducer. The architectural configuration supports this hypothesis. The sarsen circle and the inner horseshoe of trilithons create a sound-reflecting chamber. Archaeoacoustic research has demonstrated that the structure amplifies sound by approximately 4 decibels compared to the open environment. The reverberation time is longer than a typical room, but shorter than a cathedral, creating an environment specifically tuned to support rhythmic vocalization without muddying the sound. The resonant frequency of the chamber is 110 Hz. This frequency is not arbitrary. Controlled studies using electroencephalography have shown that exposure to 110 Hz sound waves causes a measurable shift in brain activity. Activity in the left hemisphere, associated with logic and language, decreases. Activity in the right hemisphere, associated with emotion and intuition, increases. The structure is tuned to interface with the human nervous system. Engineering a structure to resonate at a specific frequency requires sophisticated knowledge of wave physics, volume, and material reflectivity. If the goal were simply to create a temple, any resonance would suffice. The precision of the tuning suggests intent. It suggests design. Now consider the layout. The sarsen stones, composed of piezoelectric quartz, form the outer ring. The bluestones, composed of dolerite and rhyolite, form the inner rings. Dolerite is an igneous rock with higher iron content than sarsen. It is more conductive. The arrangement is alternating rings of insulator and conductor grounded into the chalk aquifer beneath. This is the layout of a capacitor, or a containment field for electromagnetic discharge. The altar stone, a sandstone block sourced from northeast Scotland, over 400 miles away, sits at the center of the array. It acts as a focal point or receiver within the circuit. A skeptic at this moment would say, "You are imposing modern electrical concepts onto a Neolithic monument. These people didn't understand electricity." And that objection is fair, but consider this. You don't need to understand electricity to observe that certain stones, when struck or subjected to pressure, produce sparks or create a tingling sensation. You don't need to understand piezoelectricity to recognize that certain arrangements of stone produce effects that others do not. If the builders were working empirically, testing configurations and observing results, they could have arrived at a functional design without understanding the underlying physics. They would have called it magic. We call it electrical engineering. The function is the same. Let's return to the transport problem. The bluestones were sourced from the Preseli Hills in Pembrokeshire, Wales. That is 150 miles from Stonehenge. The altar stone was sourced from the Orcadian Basin in northeast Scotland, over 430 miles away. The sarsen stones were quarried from West Woods, 15 to 20 miles distant. Why go to such extraordinary lengths? The standard explanation is that these stones had cultural or spiritual significance. But that explanation does not account for the precision of the selection. The Preseli bluestones are dolerite, a specific type of igneous rock with magnetic and conductive properties. The altar stone is old red sandstone, a sedimentary rock with distinct mineral composition. The sarsens are 99.7% quartz. These are not arbitrary choices. These are material specifications. The builders bypassed readily available limestone and softer rocks to source stones with specific physical properties from distant quarries. The effort required to transport these materials, dragging multi-ton blocks across 150 miles of forested, swampy terrain, is logistically absurd. unless the properties of the stone were essential to the site's function. Experimental archaeology has repeatedly failed to replicate this transport using Neolithic technology. Julian Richards' team struggled to move a 40-ton replica sarsen on a flat surface with modern ropes and 130 men. On soft soil, the sledge runners sank, acting as brakes. The coefficient of friction for dragging wooden sledges over unimproved ground is immense. The caloric expenditure required exceeds the surplus energy available to a subsistence farming society. The official story requires us to believe that Neolithic communities, with no metallurgy, no wheels, and no draft animals, transported hundreds of tons of the hardest available stone across vast distances for purely symbolic reasons. The evidence does not support the narrative. The effort makes sense only if the function required it. Now we turn to the joinery. Stonehenge is unique among stone circles because it is engineered, not stacked. The sarsen trilithons are locked together using mortise and tenon joints, a woodworking technique applied to megalithic stone. Each upright has a carved tenon, a protruding knob on its top surface. Each lintel has a matching mortise, a shaped hole, carved into its underside. The lintels are also linked end to end using tongue and groove joints, forming a continuous, locked ring. Creating a mortise in sarsen stone requires extreme precision. If the tenon is slightly too large, the lintel will not sit flush. If the bearing surface is not perfectly flat, the 10-ton lintel will concentrate its weight on the high spots, causing the stone to fracture under point loading. The fact that these stones have stood for 4,500 years proves the fit was near perfect. This level of precision is difficult to achieve even with modern diamond tools. To suggest it was achieved by pecking the stone with stone mauls strains credibility. The uniformity of the dressing, the planar surfaces, the geometrical accuracy of the joints, all of this implies a technology capable of machining stone with industrial efficiency. A comprehensive laser scan conducted in 2011 revealed tool marks on virtually every stone. The standard interpretation is that these are pecking marks left by stone hammers. But the distribution tells a different story. The stones on the northeast side, facing the solstice sunrise, and the inner faces of the trilithons are dressed to a much higher standard than the outer faces. The builders selectively polished the surfaces that would be most visible or most functionally critical. This is systematic processing, not random pounding. The stones were dressed to expose the lighter, reflective quartz matrix beneath the rough outer cortex. This polishing would maximize the stone's reflectivity and potentially enhance their piezoelectric surface efficiency. The builders were not decorating, they were optimizing. I know what you're thinking right now. This sounds like a conspiracy theory. I understand that reflex, but let's separate the data from the interpretation. The data is this: 99.7% quartz, 110 Hz resonance, mortise and tenon joints in stone harder than steel, alternating rings of conductor and insulator, transport of specific stones over hundreds of miles, deliberate burial of massive monuments, and systematic sealing of internal voids by modern authorities. These are facts. They exist in the archaeological record, the geological record, and the historical record. The interpretation is where we diverge. The mainstream interprets this as ritual. I am suggesting we interpret it as infrastructure. One of these interpretations accounts for the material properties. The other does not. Let's now address the global context. Stonehenge does not exist in isolation. The engineering techniques and material choices echo other sites around the world, sites that official history claims had no contact with one another. At Sacsayhuaman in Peru, massive blocks of andesite and diorite are fitted together using interlocking polygonal masonry. No mortar. The stones are shaped to lock in 3 dimensions, resisting earthquakes and settling. The precision of the fit rivals Stonehenge. Andesite registers at 6 to 7 on the Mohs scale. The tools attributed to the Inca builders are bronze and stone, both softer than the material being cut. At Pumapunku in Bolivia, blocks of diorite are cut with planar surfaces and right-angle corners to sub-millimeter precision. The site includes H-blocks with grooves and notches that appear to be designed for assembly, like modular components. Diorite is harder than steel. At Baalbek in Lebanon, the foundation platform includes stones weighing over 800 tons, precisely fitted without mortar. The quarrying, transport, and placement of these blocks defy the logistical capabilities of Roman engineering, despite the site being officially attributed to the Romans. These sites span continents. They are separated by thousands of miles and, according to official chronology, by thousands of years. Yet the engineering philosophy is consistent. Interlocking stones, mortarless fit, use of the hardest available materials, precision that exceeds the capability of the attributed cultures. The pattern exists. The explanation is yours to find. Let's now return to the present day. The Salisbury Plain is not a dormant heritage site. It is an active military zone with an active energetic signature. Since the late 1980s, residents of Wiltshire and the Bristol area have reported a persistent low-frequency droning noise known as the hum. The sound typically registers between 30 and 40 Hz, below the threshold of normal hearing for most people, but audible to approximately 2 to 4% of the population. Those who hear it describe it as maddening, pervasive, and inescapable. The characteristics of the hum are consistent with very low-frequency electromagnetic or acoustic emissions. The chalk aquifer beneath Salisbury Plain is an excellent conductor of vibrational energy. The plain also hosts the densest concentration of military communications infrastructure in the United Kingdom, including systems used for submarine communication and deep penetration signaling, which operate in the very low frequency range. Two possibilities present themselves. Either the ancient piezoelectric network is not entirely dormant, generating low-frequency resonance amplified by the geology, or modern military systems are interacting with the conductive aquifer and the quartz stones, creating a feedback loop. The hum may be the sound of the machine idling, or it may be the sound of new systems interfacing with old ones. The physiological effects reported by those who hear the hum include headaches, dizziness, and heightened anxiety. These effects mirror the neurological impact of the 110 Hz resonance documented in the acoustic studies. The site is still broadcasting. Now, let's resolve the story of Robert Phillips. In 2018, Phillips returned the core sample to English Heritage. Because of that core, we now know the sarsen stones are 99.7% quartz. Without his retention of that sample, the material properties of the monument would still be speculative, based on surface scrapings contaminated by weathering and lichen. Phillips kept that core in a plastic tube for 60 years. He knew what he had, and he knew why no one else was allowed to see it. Whether the suppression of the other two cores was deliberate or accidental, the result was a 6-decade data gap that prevented geologists from understanding the true nature of the stones. Phillips's return of the core in 2018 was an act of disclosure. It forced the scientific community to confront the evidence. The vindication is this: the machine hypothesis is no longer speculative. It is supported by material science. This sounds impossible. Let's check the historical context. Throughout history, successor cultures have moved into the infrastructure of predecessor civilizations without understanding the original function. The Romans repurposed Greek temples. Medieval Christians built cathedrals on pagan sites. Victorian engineers mistook ancient aqueducts for defensive walls. We are doing the same. We moved into the machine. We didn't know how to switch it on. So we used the acoustic chamber for chanting. We used the alignment for calendars. We called the cooling system a wine cellar. We called the resonant chamber a chapel. We treated the factory like a cathedral because we couldn't conceive of a function beyond our own technological framework. This is not ignorance. This is the cargo cult effect. When a culture encounters technology it cannot replicate, it ritualizes the remnants. The function becomes myth. The infrastructure becomes sacred. The builders become gods. But the stones remain, and the stones do not lie. Let's now address the civilizational implications. If Stonehenge and the Salisbury Plain complex represent inherited infrastructure rather than indigenous construction, we are forced to confront the possibility of a technological amnesia event. A loss of capability so profound that entire industries, entire bodies of knowledge vanished from the record. This is not unprecedented. The Roman Empire lost the ability to produce concrete after its collapse. The recipe for Damascus steel was lost. The construction techniques for Gothic cathedrals were forgotten during the Renaissance. Knowledge is fragile. It requires continuous transmission. When the chain breaks, the technology becomes indistinguishable from magic. The question is not whether such a loss could occur. The question is what caused it. And that question is beyond the scope of this investigation. What we can say is this. The British landscape is scarred by cycles of erasure. The dissolution of the monasteries destroyed libraries and archives. The English Civil War demolished castles and manor houses. The Victorian era saw the wholesale destruction of medieval infrastructure in the name of progress. And in the 20th century, the concrete trucks arrived at Stonehenge. We sanitize the anomalies. We make the past safe for tourism. We turn the technology into a postcard. And in doing so, we bury the evidence beneath layers of interpretation, restoration, and enforced secrecy. The Salisbury Plain is a crime scene. The evidence has been moved, sealed, and reconstructed. The witnesses have been evicted. The perimeter is guarded, and the public is told it is for their own safety. But the hum remains. The magnetic anomalies remain. The subsurface network remains. And the stones, those 99.7% quartz crystals, remain under permanent compressive load, waiting for the frequency that will make them sing. Go to Salisbury Plain, but don't look at the sunrise. Look at the joints. Look at the crystal. Look at the fences that keep you out. Look at the red flags and the cameras, and the security patrols guarding a pile of rocks that the official story claims are 4,500 years dead. And ask yourself, what is worth protecting? The lights went out 5,000 years ago, but the hum remains.